So you can always take them back home to draw on if needed, okay? But we're gonna start up here where it says a figure and its reflection are, the word should be congruent. When we are reflecting a figure, they're going to be the same size. It means it's the same shape, but it's going to be in a new location. So the first thing, here are our steps over here. We need to identify the key points in the pre-image. And again, you're not always going to see these reflections in a picture. It might just ask you to reflect one point, but for our purposes, we're just going to go ahead and learn how to do it with the whole picture, because you're going to have to reflect points to do that, okay? So look at this figure F. Notice where all of the important points, meaning all of the vertices, where two lines meet in this F image. Look at all of those. That's a lot of points, right? So this point right here is going to be 1, -1. What's this point going to be? 2, -1. What about this one right here? Go over the X. 1, 2. Up 1. This one you're going to go over 1, 2, 3, 4. Up 1. 4. Up 2. 4. Up 3. 4. Up 4. What about this one right here? Do we go over 4? Nope, that's just 1 over on the X. And 1, 2, 3, 4 up. What about these two? How many over is this line right here? 2, comma, that one's going to go up 1, 2, 3. So then this one is going to be 2, 2. That's a lot of points that we are going to flip, right? So here's what we need to do. We need to create the image so that each point maintains its distance from the line of reflection. The reason we want to call it the line of reflection instead of the origin is because if you look up top, in this image, we are reflecting over the y-axis. Therefore, my line of reflection is the y-axis. But if you look at our next two examples, the lines of reflections are different. Do you see that? So for our purpose, we need to look at the distance, in this case, from the y-axis. So this first point right here has a distance of 1 to the right. So if we're going to reflect it over the y-axis, picture a piece of paper, picture a dot at 1, -1, and then picture folding that paper over the y-axis. Your point's going to be, again, distance of 1, but on the other side. Okay? Whenever we reflect, we label the points, their notation. We label it, it's called prime notation. So let's say that we had called this point A. This point right here that we just reflected is going to be A prime. You're going to put a little apostrophe on it. That's telling your reader this is a reflected point of that original point A. You're going to do the same thing for all the points. So look right here. This next point that I'm just circling in blue, it's got a distance of 2 from the y-axis. So we're going to give it a distance of 2. Next, we have a distance of 2, distance of 2. Notice how their y values are staying the same when we reflect over the y-axis. What's changing? Their x value, because that's where they're changing on the coordinate plane. This one we're going to go over 4. 1, 2, 3, 4. This one's going to go over 2, over 4. Then we've got 2 more, over 2, over 4. Then we got 2 more. This one's over 1. And then over 1, 2, 3, 4. And now we want to see if we can connect our dots to make that F. I know my paper is kind of crazy, but look at that. Does everyone see this F image from reflecting all those points? It looks just like the one that we started with, but it's like if you take your piece of paper and you were to fold it over your y-axis, and then if you hold it up to the light, the F's should be right on top of each other. We got a black, and we got a brown, or a black and a red. All right, my challenge for you is to try the next 2 on your own. All right, guys, real quick, take a look up here at the board because we are going to do our triangle one together. So the good thing about the triangle one, unlike the F, excuse me, Ryan, this is being recorded, so when I put it on YouTube, you can show your mom. Look at those 3 vertices. Now, we are not doing diagonal distance this year, remember? So here's what I'm going to do. This first vertice, I notice I can go 1, 2 to the right. So I'm going to go over 1, 2 right there. Okay? Everyone see how I did that one? No?
What if we went down with that one too?
What? Ooh. Oh, you know why you can't go down? All right, we are going to start over with this one real quick because I did not have the reflection correct. Okay? So, we are reflecting over this line. This particular diagonal line is called y equals x, where the x and y values are equal. So like that point, you got 1 on the x, 1 on the y. That's what the line is called. But we don't really have to know that information. But we are going to fold it over the dotted line. So here's what we need to do. Notice how I went 2 units to the right. Because we're going over that dotted line, if I just kept going 2 units to the right, it's actually going over a vertical line. And the line here isn't vertical. So now I need to actually turn my movements. So now I'm going to go 2 down to create that fold in the paper to reflect it over that point. So this is going to be point 1 prime. So you can't just go in the same direction. So like Camden went all the way down, 2 down and then 2 down. That would be reflecting over a horizontal line. When I was doing it, I was reflecting it over a vertical line. But that's not the case that we have, right? So instead, you're going to have to shift your distance to go along with the dotted line. So let's look at this point. I'm going to call that point 2. Okay? If I go 1, 2, 3, 4, 5, 6, 7, 8, am I going to go up, down, left, right? Down. 1, 2, 3, 4, 5, 6, 7, 8. And that's my 0.2 prime. So see how I'm making that fold in the paper? For future reference, you will be being asked to reflect over the X and Y axis, but why not learn something that's harder so that we know how to do it well? Okay? Our last point, I can go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And which way am I going to go now? The right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 0.3 prime. And now I can just connect the dots. And if I was to fold that paper, would those dots match up?
Yes.
Yes, Camden.
I just turned my paper like this.
That's a great strategy too. Just physically turning your paper so that it looks, I can't turn it on the screen, so that it looks more like a vertical line. That works as well. Dennis?
I thought we were reflecting across the origin.
Nope, not across the origin, across the dotted line. Alrighty. So this is the answer key for Blue Math's numerical patterns and relationships practice. If you need to look at this because you were not in class, just pause the video here after you completed it on your own.